Hi everyone, a good evening to all. Today we are going to study about the elastic potential energy. So it's all about what is the elastic potential energy stored in a stretching wire. Now when you take a wire and like attach it to one fixed support, you apply a force, then it stretches by some length. Let's take the stretch in the length is delta L. Then the work done by the force is half into F into delta L, and this work only will be stored as elastic potential energy. And when you consider in case of stretching a wire, Young's modulus is FL by AY, so that when you don't know F value, delta L, so YA delta L by L or delta L equal to FL by AY, so that work done or potential energy is also equal to half into F into delta L or half into F value if you substitute YA delta L whole square by L, or if you substitute delta L half into F square L by AY. Means in a question, if F and delta L is given, then the question is simple. But if F is not given, if delta L is not given, then you may have to manipulate the formula. That is what this thing. Now the next thing is, what is energy density? See, energy density means energy per unit volume. That is the formula. So energy per unit volume means energy by area into length, where energy is half into delta L by A into L. So the energy density is half into F by A is called stress. Delta L by L is called strain. And this is also equal to half into stress. I can write it as Y into strain. So Y into strain whole square. Or else strain I can write it as stress by Y. So stress whole square by Y. So this is what the energy density. So please just try to remember the formula, then you can solve the question. And sometimes it's not very frequent, but sometimes they will ask the question based on the relation between all the four quantities, that is y, b, neta and sigma. That is y equal to 3b into 1 minus 2 sigma and y equal to 2 neta into 1 plus sigma, where sigma is Poisson's ratio, y is Young's modulus, b is bulk modulus, eta is rigidity modulus. So just remember the formula and try to understand the question and try to solve it. So and sometimes comparison based questions also they can ask, like as we discussed in the previous question based on the same chapter, how they ask the question like comparison of Young's modulus between two wires. Same way they can ask here also, like comparison based questions on work and energy. Now here is our first question. A wire suspended vertically from one of its ends is stretched by attaching a weight of 200 Newton to the lower end. So the force applied is weight of the body, that is 200, and it stretches the wire by 1 millimeter. 1 millimeter nothing but 10 power minus 3 meter. The elastic potential energy stored. See, it's a direct question. So half into F into delta L. So one simple question. So a simple question can be expected from any chapter, from any concept on any formula. So you just have to take care of remembering formula, collecting data, conversion of units and proper calculation. Now the next question is, a material has Poisson's ratio 0.50 if a uniform rod of length here suffers a longitudinal strain. So longitudinal strain delta L by L they have given as 2 into 10 power minus 3. Then the percentage change in volume. See, volume is actually pi r square h r L. So that here delta V by V equal to 2 delta R by R plus delta L by L. and sigma equal to minus delta R by R by delta L by L, lateral strain by longitudinal strain. So that delta R by R, I can write it as minus sigma delta L by L. So that delta V by V, I can write it as 2 into minus sigma delta L by L plus delta L by L. So that delta V by V, if you take delta L by L common, 1 minus 2 sigma. Sigma value they have given, delta L by L value they have given. Sigma is 0.5. So if you substitute, you can get it. Or you can remember this like a formula also. Now, the Young's modulus of the material of a wire is, so they have given Young's modulus, that is 2 into 10 power 10 Newton per meter square, and percentage change they have given, so delta L by L will become 1 by 100. Then the energy stored in the wire per unit volume. So strain and this they have given means energy density they are asking. Energy density equal to half into stress into strain. But here they are asking the formula in terms of Y and strain. So I can take it as Y into strain whole square. So that Y is 2 into 10 power 10 and strain is 1 by 100 whole square. So that way you have to collect the data, then you have to choose the proper formula because there are 3 formulas. Which one to be chosen? Immediately you must recognize it from the given question by understanding, by collecting data. Now the next question. 2 wires of the same material and same length but diameters in the ratio 1:2 are stretched by the same force. Now force is same and their diameters nothing but radius are in the ratio 1:2. The potential energy per unit volume they are asking. See the potential energy per unit volume and same material means Y1 equal to Y2. Same length means L1 equal to L2. Then energy density means half into F into delta L by A into L. Now force is same. Here delta L they did not talk about anything. So that half into F by AL into delta L, what I can write is FL by A into Y. So that half into F square LL get cancelled by A square Y. Where F is same for both of them, Y is same for both of them. So energy density is inversely proportional to A square. So that inversely proportional to R power 4. So that U1 by U2 will become R2 by R1 whole power 4. Where R1 by R2 is 1 by 2. So R2 by R1 will become reverse 2 by 1 whole power 4 means it will become 16. So that is what I said, comparison based questions. Comparison based question means you have to find out, you have to take the general formula, then you have to find the proportionality relation with the variable quantities, then you have to take the ratio. Then the last and final question, calculate the energy stored in a 2-meter long copper wire of cross sectional area 0.5 into millimeter square means 10 power minus 6 meter square. And a force of 50 Newton is applied to it. So length is 2 meter and cross-sectional area they have given, force they have given, and Young's modulus they have given 1.2 into 10 power 11 Pascal. See, energy stored means actually half into F into delta L, but here no delta L. Then I said to manipulate the formula that delta L is FL by A into Y, so that the work done will become F square L by AY. Now if you look at the data, every data is available. So that is what you may have to take the direct formula, you may have to manipulate the formula whichever you are having. But these kind of questions you will get based on the elastic potential energy. So please just try to remember and try to solve, and similar questions I have given as an assignment, 5 questions. Just try to do it so that you will get the idea how to do the questions. So thank you all. We'll continue in the coming session with the next question.